Good morning. Welcome to the Mission Control Center here in Houston. We are working today on, or we're talking today rather, with the principal investigator of one of the experiments the crew worked on earlier this week, the body measures experiment. One of the main things that we are trying to learn as the crew lives in space for these long periods of time is how that stay in space affects their body. And the body measure experiment looks at exactly that. So this is Sudhakar Rajulu, who's going to be telling us a little bit about that experiment. Thanks so much for joining us.
Oh, you're welcome.
So tell us, first of all, just explain kind of what the body measures experiment is.
Right. The body measures experiment is to understand when crew members spend the time in space, how their body dimensions change. Like, for instance, the height, the stature of the person, and also circumference, because there are fluid shift that happens that, you can see the crew member's face in space, kind of like puffed up, because of the fluid shift from feet to the head. So there are changes in the taper that happens in space that could affect how they are wearing the suit, for instance.
This is a space suit, or?
It's a space suit, yeah. So when crew members go into space, because of some changes that happen to their stature and things like that, they need to be resized in space. So because of that, there are things that do not uh, remain the same as they were measured on the ground. So when they go into space, you have to adjust for those things. And that's what the reason for the testing.
Okay, so you see a number of different changes, it sounds like. You mentioned that you can even observe from the ground that their faces get maybe a little puffy.
Right.
That's from the fluid shift. You also, I think, said they get taller. Is that right?
They do get taller, and it varies from person to person. But in general, there is a growth in space. It's because of the elongation of the spine.
And are those changes permanent?
Those changes remain so long they are in space, but when they come back, most of them revert back to the normal position.
Okay, so you just need to, you can't really measure on the ground when they get back what it's like, so you measure it in space.
In space, right.
So how does that work? What does that look like?
What do you mean, how does it look like?
How did they actually go about taking those measurements in space?
Well, if you're on ground, we have different devices to measure them, like anthropometers and different devices that we have. It takes time also to do that. In space, what we're doing is using what we call video analysis. We take pictures of the crew members in specific postures, and
I think here's
it's an example, like we identify the markers on the body, and we place some reflective markers on the specific landmarks on the body. We identify those things before they go into space, and we place those markers and take, when we take a picture using photogrammetric technique, we can then identify the distance between two of those markers. So, for instance, we place one on top of your head, and we know where you're standing on the floor. So the distance between the head to the floor will give us the height.
Okay.
Same thing with the shoulder height. We put markers on the shoulder.
Okay, little more complex than just marking it on the wall like you might do for a kid at home.
Right. I mean, you can do that. I mean, crew members have done that. But since we are concerned about sizing precisely the suit, we need to have scientific measurement techniques and repeatability, so that when we tell the sizing engineers how much you have to allow for it, it'll be more precise.
Okay.
Yeah.
So why is that important? Why exactly do we need to know precisely what these measurements are?
Well, for instance, like I said, the suits are sized before the crew members go in space. When we had the shuttle, the crew members had their own suits, and they would have been adjusted to account for some changes. Unfortunately, with the shuttle being retired, we are now relying on the suits that are on the station. And If you don't size them properly, you may run into difficulties in getting into the suit, or it may be uncomfortable for you. In fact, recently, about 6 months ago, we had a crew member who had just a little bit tight fit into the suit. So it is necessary for us to help the sizing engineers to account for it. And if it is variable from person to person, then we can then inform the crew members how to size themselves in space. We don't have the luxury of having the suits sent by the shuttle like we used to do before.
Okay. And I guess it's really important for the spacesuits to fit well as they are doing
Absolutely,
spacewalks.
yes. Because you don't want to be in a suit for 8 to 10 hours and having to deal with discomfort, and that may distract you from doing the tasks, or you may have to not have a successful mission, and which is a very difficult thing to do when you are planning for important tasks and you're going to be out in the suit for 8 hours or 9 hours. We need to make sure that it is as comfortable as possible for the crew members.
Okay. So I guess that's even if they're not necessarily doing a spacewalk now, they're still participating maybe in this experiment. I guess they were taking some measurements yesterday for the experiment. Do you,
Right.
when they are on orbit taking the measurements, you talked about putting the reflective markers on and taking the measurements. Is that the extent of it, or is there more?
Well, what we want to do is that certain measurements, like here's an example of the setup, how we want the crew members to be measured. There are certain things we also want to capture. In doing the Skylab, what we found was that as soon as you go into zero gravity, there is this sudden increase in the height, and there is another phase where the height was still growing a little bit. So it kind of like it took a while for it to plateau it out.
Okay.
So we also want to measure the durational change. If is there a growth continuing throughout the mission, or it kind of plateaus out. So we have periodically measuring these measurements, not just the height, but also circumference at the chest, calf level, and thigh circumference. The reason for that is that we want to make sure, if we want to tell the sizing engineer, you need to make this adjustment. Is it something going to remain constant throughout the mission? Because the crew members are going to be there on the space station for 6 months to 3 to 6 months. So if it's changing, we need to be able to account for it. Otherwise, we can say it's a constant sizing delta that they can apply to it.
Okay.
So we are measuring periodically.
Okay. Well, just one more question, and then we'll wrap it up. We always like to hear about it. This sounds pretty specific to spaceflight, but are there applications for us here on Earth as well? Are there any benefits?
Well, right now, I think it's more specifically geared towards suit sizing. But one thing we notice is that we just finished one data collection. One crew member had participated. We haven't even finished the analysis yet. But we're noticing that calf circumference changes a lot. It actually decreases. And that's mostly because of the muscle atrophy. But it's still preliminary. Ultimately, what we really want is clothing and suits are self-adjustable, right? And if we find that there are means to do that, that may have impact also. And then also we have better studies. We have similar situation that happens for the subjects undergo changes in the body dimensions. So there may be some benefit there too. Yeah.
Okay, well, great. We look forward to hearing more about that. Thank you so much for coming and speaking with us. Again, this was Sudhakar Rajulu, who is the principal investigator for the Body Measures experiment. Thanks so much.
Thank you.